Good day, learners. My name is Tandile. My surname is Buntu. I'm the Science Advancement Unit Manager at Science of Space Science in Hermanus. My background in education is chemical sciences and physical sciences, and I did a postgraduate certificate in science communication as to how to communicate science in a better way. I'll be doing a demonstration with you guys based on chemical reactions. It's a simple demonstration that is fun to do, that is interesting, that anyone can do anywhere they want to, as long as you have the right apparatus and the right chemicals to do it. It's safe, it's easy enough to do. But before I do that, I just want to align the safety measures. You need to wear a lab coat, you need to have your gloves on, you need to have your goggles on, just in case there are any splashes that might touch your ears and also your eyes. So in that manner, you need to be safe and to take some precautions. So in front of me, the apparatus that I'm going to be using is lime water, as you can see guys here. And we have an indicator in this form, which is a phenolphthalein indicator, or if you don't have this one, you can use a bromothioate blue. And then I have droppers, about 3 of them. And then I have beakers, which is about 200 mils. And I have distilled water. I have a straw, and I have something to shake with. Show you guys is how carbon dioxide neutralizes oxygen within a solution. How oxygen and carbon dioxide react amongst each other. So to do this, what I'm going to do is to pour in some distilled water in the beaker up to roughly about 200 mils. Okay, the easiest way is to do this. So about 200 mils, let's do this. I'm going to put 200 mils in each. Okay. Now, the next step to do this is to have an indicator, which we can put about 10 to 12 droplets of an indicator in one of the beakers. So if you can count with me, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And then thereafter, we're going to be putting lime water. About 3 mils of lime water into the same beaker. 3 mils of lime water, which is this 3 mils, perfect. Okay. Notice the color changes here. And I will stir this with my stirring rod. I'm sure you guys can see the difference between the two beakers. This one is clear, which we didn't put anything in. This one has a pinkish color, where we have our lime water, which is our calcium chloride, and we have our indicator. So the indicator acts as a base, and at the same time it acts as an acid to determine if we have an acid or if we have a base. So this is what we're going to do, guys. To prove my theory that this is going to work, I'm going to breathe through the straw. So I will just exhale. Oh, this needs a lot of breathing. As you can see, guys, the pinkish color is starting to vanish away. In fact, it's gone now. Now, what happened here is that, as you know that you guys, when you breathe, we breathe oxygen. And then we inhale oxygen, but when you exhale that, you know that you guys exhale carbon dioxide. Now what happened is that we had water, which was a solution of lime water and your distilled water, and then we added an indicator. And then on this side, we're going to test for this side if the same thing is going to happen or what's going to happen in this one. Let's do this. Nothing happens. Now, so what happens is that if you have enough of this carbon hydroxide going into your solution, which was your base, and then you had an indicator, what you do here, you're just neutralizing your solution. You make it now to be more of an acidic solution. As you can see, we started with this color, which is a colorless color, and then we throw in the indicator, we put in the solution, which is your lime water, which is calcium hydroxide, and then the indicator indicated that the solution now is base. But we wanted to neutralize this solution to be acidic, and then we use the carbon dioxide that you exhale when you're breathing out. So if you have enough carbon dioxide coming out and then mixing it with the solution, and then what you do is just neutralizing the solution itself. Now, just to give you guys some basic life examples where some of these reactions also is something that you might do at home. Now, I want you guys at home to use vinegar. Take vinegar, have a beaker or have a glass of water, have a glass, and then take your vinegar, have an egg, a raw egg, put the raw egg in the vinegar, and then throw in your vinegar and leave it just for a night, just overnight, and then you will see in the morning your raw egg will be cooked. Now the vinegar acts as your acid in that form, and then your egg will act as your base, and then the more vinegar you have, then it will be able to cook in your egg. Now to just give you guys as to the applications of these chemical reactions as to where you can use these, obviously you can use these in labs. Currently, guys, as you might know, we're having a challenge with COVID. And to find a vaccine for COVID, they need to mix, they need to do a lot of tests, and those tests involve using a lot of chemicals, involve mixing a lot of chemicals. So to do these kind of things, you will need to work in a lab, a laboratory, and in South Africa we have a lot of laboratories. You can work at Lancet, you can work at the SAPS one, you can work even at hospitals, whether it's a public hospital or it's a private hospital, but all hospitals have their own laboratories. You can work at pharmacies, and then in all those people that have labs, they deal a lot with chemicals. But in this manner that we did, we use simple basic chemicals to prove a base, to prove an acid. Thank you very much, guys. I hope you enjoyed.